Yeah.
When you go to a private salon, I forget.
All right, Riley,
Make sure to tell us.
what are the two problems for this one? I did say Riley.
Oh. The same thing, and then you just flip the ending. So you flip the 9 and then make it -7.
Good. It's an and problem because originally it's less than, remember? So when I graph my solution, Allie, when I graph my solution, I'm gonna make sure I look to see where the two graphs overlap, right? Usually they'll go towards each other. So this part's easy for you guys, right? All this is easy, I know, but that's okay. Okay, so a few people, remembered to do this part. Then some of you forgot to graph the solution. Okay, I know some of the directions said use interval notation and stuff. I'm just going to have you guys do the graph, solve and graph. Okay, so -2 would be down here, 0 is about here, and then we got 5 and 6. Kind of get an idea where we're at. Now, yesterday, all of our examples had the equal to. This one has no equal to, so where do I put it? -2 and 5. Circles, yeah. Don't fill it in. All right, lesson 5 would go this way. And greater than -2 would be this way, and it's an and. Remember the less than ones are ands, which means we're looking to see where they overlap. So all the numbers between -2 and 5 would work in that original inequality. Any number less than -2, including -2, actually, -2 or less, or 5 or bigger, if I put it in there, it won't work. Because if I put 5 in there, I get 7. What's the absolute value of 7? Absolute value of 7? 7. Is that less than 7? No. Right? So again, when you have a quiz on this next week, I'm just going to ask you to solve and graph, even though your directions in your homework said use interval notation. It might even say that today. Again, just always solve and graph these. Going over the homework, number 3, x is less or equal to -6. So you have an open circle at -6, arrow to the left. For number 6, x is less than or equal to 5/6, which would be just about the 1. So you have a dot between 0 and 1, closer to the 1, and an arrow to the left. Number 9, x is less than -3/4 and, I'm sorry, I said that wrong. X is greater than -3/4 and less than or equal to 4. So you have a circle at -3/4, which is just about at -1. And then a solid dot at 4 and connect them. Number 12, -3 is less than or equal to x, which is less than or equal to 24, meaning a solid dot at -3, a solid dot at 24, and you would connect those. 15, x is less than 1, or x is less than -1. They went in the same direction, so you'd have to use the circle at 1 and an arrow to the left. That would take care of the -1. Any questions up to 15? So 15 was 1. Usually the ors go opposite directions, but that one, they went the same direction. 18 is a circle at 1 and a circle at 8 and connect them. Greater than 1, less than 8. 21, x is greater than or equal to negative 4/3 and less than or equal to 8. So negative 4/3 is just past the negative 1. So we have a solid dot just past negative 1 between negative 1 and negative 2, and a solid dot at 8, and connect them. For 24, x is greater than negative 1 and less than, greater than or equal to negative 1 and less than or equal to 4. So solid dot at negative 1 and 4, and then connect those. 27 is just 4. I want to show that one, go over that one with you guys, just to make sure you understand why. Okay, so I believe that was the problem. Yeah. So my two problems are x minus 4 is less than or equal to 0, and, because it's less than, x minus 4 is greater than or equal to negative 0, but you really can't make it a negative 0. There's my two problems. Add 4 for both. So x is less than or equal to 4, and I don't really need to worry about that, I guess. Okay, so when I graph this, all right, if I do this one, it's a solid dot at 4 going to the left, because less than. This one is blue, that's a solid dot at 4 going to the right. Since it's an and, where do they overlap? Just on the 4. That's why the answer is just 4. Okay, so all you'd have would be that solid dot at 4. I saw some people had, a solid dot at 4 and then arrows going both ways. That would be telling me that everything works. Okay, the only thing that does work is just the number 4. Okay, one other thing I wanted that we didn't really look at, but I just want to ask you guys, what do you think about this problem? What's going on here? Did you say, Riley?
Wouldn't you just make it positive and total?
Flip it. But think about this one. What's absolute value mean? We said yesterday, how far from what? 0 on the number line. It's a distance, which is always what? Positive. Will the absolute value of something ever be less than or equal to a negative number? That'll never happen, will it? So every now and then they'll try to trick you and put a problem like this, put less than, and they'll put a negative over here. Less than or equal to. Greater than's okay, right? That would be okay. But if it's less than a negative absolute value, that's never going to happen. All right? And we didn't run into one of those. We didn't run into one of those in an example or for homework. Sometimes we run into those on homework, but we didn't. So I just wanted to show you that sometimes they'll try to trick you. So don't get tricked. Okay, any issues with regular, basic inequalities, compound inequalities, or absolute value inequalities? Pretty simple, right? All right, today we're going to do quadratic ones. So when we do these, it's always 0 on the right. So we want to make sure everything's in the right order. And what do we usually do when we see quadratics and want to try to solve? Starts with an F. Factor, yeah. So we're going to factor these. All right. So Trey Go ahead. Very good. The 5's negative and the 3's positive. When I multiply them, I get negative 15. When I add them, I get negative 2. It's a regular, basic trinomial. A is 1, so it's really easy to do, right? Now, what did we do when it was an equation, when it was equals? We weren't done here. What did we have to do with each factor? Set them equal to 0. We're doing the same thing. So what are my two answers? Negative 3 and positive 5. I'm just throwing some blue in there every now and then. On the Fritz. So we call those critical values for this problem. And again, we're solving and graphing. Okay? So what we do is we get our number line. 5's up here. Negative 3's down here. 0 is somewhere in here. Okay? And since it's less than or equal to, we'll put a solid dot at those two numbers. And what's happening here is those two values are splitting our number line up into 3 sections. Okay? So we got to figure out if we're going to draw an arrow going left, connecting the two, or an arrow going to the right. Okay? So what we do is we take test numbers or test values from each section and plug it into the original problem. If the number that you pick works, then you're going to draw an arrow towards that number. If it doesn't work, then you won't worry about drawing an arrow that way. Okay, so the numbers I usually pick are really close to these. So this is negative 3, so what's the next number closest? Negative 4, right? So that's what I would pick for my test value. So I go negative 4 squared minus 2 times negative 4 minus 15. So that's positive 16 and a positive 8, negative times negative, which is 24, minus 15 is 9. Is 9 less than or equal to 0? No. So I would not draw an arrow towards that direction. That means all the numbers this side of the negative 3 don't work. Okay? Now what's an easy number to pick between negative 3 and 5? 1's an easy number. What's even easier than that? 0. If 0 is one of my choices to pick, if it's not one of the critical values, I'm going to use 0. Okay, but 1's okay. Anything in there is fine. When I put 0 in, zero minus 15 is negative 15. Is that less than or equal to 0? Yes. So I would connect those. That means the numbers in that section will work. Okay? And then what do you think the easiest number to pick after the 5 would be? 6, yeah. But you can pick any number. You can pick big numbers if you want. But I always try to pick the ones that are closest to them on either side. So I go 6 squared. Leave this in there. Minus 2 times 6 minus 15. So 6 squared is 36. Minus 12 minus 15. That comes out to 9 also. That's not less than 0 or equal to 0. So it would be that area. Okay? Does that make sense? Okay. I got one for you guys to try, and then you can start your homework. You guys try that one, please. Give you a few minutes, and then we'll go over it. wanna figure out the graph. That's your check. You're checking, pick a number on this side, pick a number in there, pick a number there. Since that's -3, I went to the next number. You can pick any number, it just has to be less than anything else. Yeah. And then if the zeros are not, you can zero it. Guys are all getting it, good job. So where's, on your graph, where do you draw the line? In between them, isn't it just like the last one? Except we gotta remember on our graph, our circles are what? Open, yeah. All right, so +4, -1, so it's -4, +1 for our answers, our critical values. So -4 is down here, +1's here. Open circles because it's not equal to. And I would try -5, I would try 0 and 2, the ones I would try. So -5 squared is 25. 3 times -5 is -15 minus 4. So 10 minus 4, that would be 6. That's not less than 0, so that didn't work. 0 is square root of 0. 3 times 0 is 0. Minus 4 is -4. That is less than 0. And then 2 squared is 4. Plus 3 times 2, 6 is 10. Minus 4 would be 6. And that's not less than 0. Okay? So remember, what's always the first thing you do when you're trying to factor them? Riley? Yeah. Somebody said that. Was that you, Lexi, or was that Julian? Oh, it was Allie. I can't tell when the masks are on where it's coming from. Yeah, so always look for a GCF first, right? And then go from there. All right, good job, like always. 4 problems. You just gotta get it done before you leave. And submit. Then you won't have to worry about any math homework tonight. Good start for the new 9 weeks. Yes. You're doing an awesome